Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 3 to the power of x plus 3 to the power of x is equal to 10. So I'm going to find the value of x here. So for my solution, first start with 3 to the power of x plus 3 to the power of x is equal to 10. Now, because I have 3 to the power of x on my left-hand side, I'm simply going to factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times 1 plus 1 is equal to 10. Now 1 plus 1, that's equal to 2. So now I have 3 to the power of x times 2 is equal to 10. Now if I divide both sides by 2, these two cancel out. Now I'm left with 3 to the power of x is equal to 10 divided by 2, which is 5. So now I just got another equation, 3 to the power of x equals 5. So now to solve this, I'm going to first take the log on both sides. So now I have log 3 to the power of x is equal to log 5. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And what's so important about this property is that right now, as you see, x here, this is an exponent. And it's really hard to solve for x right now the way it is because x is actually going to be a decimal. Because we know that 3 to the power of 1 is equal to 3, and 3 to the power of 2 is equal to 9. And 5, this is somewhere in between 3 and 9, meaning x is somewhere in between 1 and 2. However, we can't find that exact value the way it is right now. So now that if we move x to the front, now x will be a real term, and it's going to be much easier to solve for it. So I have log 3 to the power of x is equal to log 5. And now if I move x to the front, I get x times log 3 is equal to log 5. And now if I divide both sides by log 3, these two cancel out, and I'm left with x is equal to 0.699 over 0.477, which is equal to 1.464. So this is my answer. All right, so I have 8 to the power of 16 plus 8 to the power of 16. So for my solution, eight here, this is the same thing as 2 to the power of 3. So now, if I go ahead and substitute in 2 to the power of 3 for 8, I get 2 to the power of 3 to the power of 16 plus 2 to the power of 3 to the power of 16. So now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So these two simply just multiply. So in this case, I have 2 to the power of 3 to the power of 16. So we can think of a as 2, m as 3, and n as 16. So this would be equal to a to the power of m times n. So 2 to the power of 3 times 16, and 3 times 16 is equal to 48. So now I have, 2 to the power of 48. So now I have 2 to the power of 48 plus 2 to the power of 48. So now from here, if I factor out 2 to the power of 48, I get 2 to the power of 48 times 1 plus 1, because 2 to the power of 48 divided by 2 to the power of 48 is 1. Now 1 plus 1, that's equal to 2. So now I have 2 to the power of 48 times 2. Now 2 here, this is the same thing as 2 to the power of 1. And now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 to the power of 48 times 2 to the power of 1, this is equal to 2 to the power of 48 plus 1, which is equal to 2 to the power of 49. So this is my answer. All right, so I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. So I want to find the value of x here. So for my solution, first start with 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. Now the first thing I'm going to do is, for my left-hand side, I'm going to factor out 3 to the power of x. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 1. Now if I simplify what's in the parentheses, I get 3 to the power of x times 3 is equal to 1. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So we can think of 3 as 3 to the power of 1. So 3 to the power of x times 3 to the power of 1, that's going to equal 3 to the power of x plus 1, which is equal to 1. So now, anything to the power of 0 is actually equal to 1. And because we want these two to be the same bases, I'm going to change 1 to 3 to the power of 0. So now I have 3 to the power of x plus 1 is equal to 3 to the power of 0. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x plus 1, this is equal to 0. So now to solve this, all I have to do is subtract 1 on both sides. These two cancel out. Now I'm left with x is equal to 0 minus 1, which is negative 1. So now to check, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. So now if x equals negative 1, I have 3 to the power of negative 1 plus 3 to the power of negative 1 plus 3 to the power of negative 1 is equal to 1. Now if I have something in the form a to the power of negative n, this is the same thing as 1 over a to the power of n. So 3 to the power of negative 1, that's going to equal 1 over 3 plus 1 over 3 plus 1 over 3, which is equal to 1. Now 1 over 3 plus 1 over 3 plus 1 over 3, that's equal to 3 over 3, which is equal to 1. 3 over 3 divided by, 3 divided by 3 is 1. So I have 1 over 1, 1 equals 1, which is right, so my solution is right. Alright, I'm going to start off by factoring out 9 to the power of x from my left-hand side, because all my terms are 9 to the power of x. And from here, 1 plus 1 plus 1 is going to be 3. So I get 9 to the power of x times 3 is equal to 999. So now I can divide both sides by 3 so we can isolate x. So now I get 9 to the power of x is equal to 999 divided by 3, which is 333. So now we have a much simpler equation from what we started with. So now to solve this, what I'm going to do is rewrite 9 as 3 squared. So now I have 3 squared to the power of x is equal to 333. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. Meaning 3 to the power of 2 to the power of x is equal to 3 to the power of 2 times x, which is just 3 to the power of 2x. So now this is equal to 333. Now what I'm going to bring into this equation are logarithms. And it's always useful to use logarithms when solving exponential equations because they're very helpful. And one of the reasons they're helpful is because they come with an important property that states that log a to the power of b is equal to b times log a. Meaning log 3 to the power of 2x, I can just move this 2x to the front. So I get 2x times log 3 is equal to log 333. And now I'm going to divide both sides by log 3. So I get 2x is equal to log 333 over log 3. Now I'm going to rewrite log 333 as log of 3 times 111. And if I have something in this form, this is the same thing as log 3 plus log 111. Now this is the same thing as log 3 over log 3 plus log 111 over log 3, which is equal to 1 plus log 111 over log 3. Now log 111 is the same thing as log of 3 times 37. So now this is equal to log 3 plus log 37 over log 3, which now it turns into log 3 over log 3 plus log 37 over log 3. And this is equal to 2 plus log 37 over log 3. So now if I divide both sides by 2, these two cancel out, these two cancel out. So I get x is equal to 1 plus log base 3 of 37 over 2. And this is the same thing as 1 plus log 37 over 2 times log 3. So this is my solution to this equation.